And it's back and we're starting. 4-3, operations with polynomials. How do we add, subtract, and multiply polynomials? First of all, we need to define what a monomial is. We talked about it last week. Remember I said like the monorail at Disney, it only has one rail? Monomial, a function in the form of f of x equals ax raised to the n. So pretty much anything with an exponent is a monomial. What's that? That looks good. Oh, no bueno. I usually drink those if I'm starting to feel sick. Alright, so that's a monomial. A polynomial. Poly means many. Two or more monomials.
That's when they're just like separated
by plus or minus. You're exactly correct. Alright. Trinomial is a polynomial. It's just classifying it more. Alright, example 1. Determine whether each expression is a polynomial. And this is just like your homework. A x to the 6th plus the cube root of x minus 4. No. This is just like your homework right here. So question, is this in the form ax raised to the n? Yes. Is this in the form ax raised to the n? No, this is not. This is a cube root of x, so therefore this is not a polynomial. So your answer is no. It's just that simple.
That's it?
Mm-hmm.
I like it.
Well, today's lesson is really not that difficult. I would lie to you, but I'm not currently. Alright, B. 5, a to the 4, b to the 1, plus 3a squared, b to the 7, minus 9.
Yes.
Yes, it is, because they're all in the form of ax. Now, if I was to ask you, what is the degree? What is the degree? Hold on. Degree is the biggest exponent per term. But you have to add them. So, like right here, Kyla, we have 4 and 1, which equals, so the degree of this monomial would be 5. What would the degree of this monomial be? So your biggest degree is 9. That's it. That's not hard. No. All we're looking at is the exponents. So for this one, 4 and 1, the degree of this term would be 5. The degree of this one, 2 and 7 is 9. So you want the biggest degree.
So like the biggest side.
The biggest exponents. Yep. I got it. Thank you. I'm trying to be festive. Alright, letter C. Yes. Two or more polynomials? No, it's two or more monomials. Thank you. All right, ladies and gentlemen, I apologize. I made a mistake. It's not two or more polynomials. It's two or more monomials. Sorry about that. Thank you, Ty. Monomials. Sad thing is, Ty, look, I had it right there in my actual notes. I don't know what happened. Brain fart. It happens.
So you have to rewrite them every class period.
I do, because if I wanted to, I have them on PowerPoint. I could just put but then I lose time in pacing, and to me it's harder for me. It's easier for you because it's written nicer, but it's harder for me. Letter C, 2/3, and I only have 2 classes of Algebra 2 honors, so it's not like 2 years ago I had 6 of them. That was a lot of records. 2/3 x to the negative 5 minus 6x to the negative 3 minus x. And I actually, you know the weird part of let's continue the lesson. I'm recording now, so we'll talk about it later. All right, is this a polynomial? No, it's not, because of the negative. So how would we actually write those? You're not allowed to have negative exponents. So first, let's say I had x to the negative 5. That's really 1 over x to the 5th, which we'll cover that later in the course. So those are not polynomials.
So do we not need to write the entering this part?
I was just showing you. That was a demonstration purposes only. It's just no. You will see that again on your homework.
So it's because of the negative, so like no.
Because it's not in the form ax to the power. Because you're not allowed to have a negative as a exponent. All right, let's move on. Example 2. We have 5 examples, but this is only one that had multiple parts, so let's do some actual math now. All right, girls, you'll have 20 minutes today and all day tomorrow to talk. All day Wednesday to talk, all day Thursday, and all day Friday. Just not today, please. It's midterm review. So, all right, 6x cubed plus 4x plus x squared minus 7 plus parentheses 2x cubed minus 8x squared plus 3. We've actually already done this in here. We did it with imaginary numbers. All you're doing is adding like terms. So do I have any other x cubes? So 6x cubed plus 2x cubed is, and what I'm going to do is just cross them off once I use them so I don't get confused. You don't have to use a highlighter, that's fine. That's fine. All right, so next, it's better math to go in standard form, which means by exponent. So my next largest exponent would be an x squared. What's x squared minus 8x squared? Negative 7x squared is correct. Thank you. I just like highlighters because you can still see them. That's the only reason. Do I have any x's by themselves? Yep, just a 4x, so we bring that down. And then do we have any plain numbers? Negative 7 plus 3 is, you are done. That's your final answer. That is a polynomial, but it doesn't ask you that. And the degree would be 3. I think there was someone knocking on my door. All good, all life is all better, going about our business. What is that? Someone has an anchorage, yeah. Hello, kettle. I definitely have one too myself. All right, Jonna. Not right now when we're done with the notes. We need to go to the prayer and college center. I don't know what for. That's all set. All right, we're done with example 2. Let's go on to example 3. So we just added. What do you think example 3 is?
Subtraction.
You are correct. All right, 3x squared y squared plus 2xy squared minus 2x squared y squared plus 3xy squared minus 2x squared. So before I can do anything, what do I have to do with the negative sign? That's the only difference. So I'm just going to bring this one down here. 3x squared y squared plus 2xy squared. I didn't do anything with the first term, I just brought it down. But now I need to multiply the negative by these. Negative 2x squared y squared minus 3xy squared plus 2x squared. And once we do that, same exact thing as we did on adding, we just combine like terms. 3x squared, in order to be a like term, it needs to have the same exact variables and the same exact exponents. Do I have any other x squared, y squareds? Yes. So 3x squared, y squared minus 2x squared, y squared is simply 1x squared, y squared.
So that was just the first one, right?
Yep. Yep. Do I have any other xy squareds? Right here, xy squared. So 2 minus 3 is negative 1. Do I need to write the 1? You don't have to. It's your world. You can if you want. McGraw-Hill might mark it wrong, but we're not doing McGraw-Hill, so it doesn't matter. And does this... Alright, does this 2x squared have any friends? So just bring it down. And you are done with problem example 3. 2 more examples, 2 sentences, and we're done for today. Coffee break. All right, example 4. Is this notes? Yes, this is notes. Yep. So we've added, we've subtracted. What's next? All right, let's multiply. 2m plus 5 times 3m squared minus 4m plus 2. We've talked about foiling before, first, outer, inner, last. Can I foil a binomial and a trinomial? No, you cannot, because there's no inner, outer, inner, last. It just doesn't make sense. So all you have to do is do distributive property twice. So 2m times 3m squared is 6m squared. You're fine. 2m times negative 4m is, well, 1 plus 2 is 3. And then 1 plus 1 is 2. And then we're going to do 2m times 2, which is 4m.
So do we just put like imaginary powers in there? And just put like,
well, there's a 1 there. There's a 1 there.
Can we just like write it? Yep. So like all m's have, so like negative 4m has power.
Yep. All right, I'm going to show you something that might be easier for you. It might be more confusing. It doesn't matter which way you do it. I think it's easier, but you do you, boo. All right, 5 times 3m squared, 15m squared. So what I'm going to do is write it under my 8m squared. You don't have to. If you want, you can put it right at the end of 4m. I'm just showing you, in my opinion, an easier way of doing this. 5 times negative 4m, negative 20m. 5 times 2 is 10. So see how my my variables and exponents lined up? So in my mind, it's just an easier way of combining like terms. So does a 6m cubed have anyone to combine with? So just drop it down. Negative 8m squared plus 15m squared is 7m squared. 4m minus 20m is negative m, and then the 10 just drops down. You're done. Like I said, we could have wrote it at the end and combined them. I just think that I'm more of a neat, orderly person when it comes to math, and to me that makes more sense. All right, last example of the year, calendar year. This one's a doozy. A doozy. It's not difficult, it's just a lot to it. mn plus 1 times mn minus 2 times mn plus 4. And I think that's enough. All right, first thing I would do is cover up the last term. We're going to pretend it's not here. Okay. All right, so like I said, I'm going to pretend it's not here. See, I must be off my game today, because normally I would have made a Jana or Annalise comment about it, but I'm just not feeling it today. About pretending it's not here. So, I'm just off today. It happens. Alright, so we can do distributive property with this. Mn times Mn is m squared n squared. Because m times m is n squared, n times n is n squared. Mn times negative 2 is... So now we do the same thing, but with the negative 2. Excuse me, but with the 1. 1 times mn is... And 1 times negative 2. Alright, let's combine some like terms. Okay. Negative 2m plus 1mn is... And now I'm going to put this in parentheses so I don't get confuzzled. So now we bring this back. Is it better to put it in front or back, or it really doesn't matter? I would put it in front just because that's the way I'm used to doing it. Alright, so I'm going to put mn plus 4. And now what am I... that's fine if you do it in the back. If you look...
Did we cube it now?
If you look on my example last period, they want to put it in back, so I did. So it's fine if it's in back. So now we're just going to do mn times mn squared, which is going to be m cubed n cubed. Mn times negative mn is negative m squared n squared. Mn times negative 2 is negative 2mn. So now we go on to the 4. And once again, you can either line up your exponents or you can put it at the end. It really doesn't matter. I'm giving you options. 4 times m squared n squared is plus 4m squared n squared. 4 times negative mn is negative 4mn. 4 times negative 2 is negative 8. Unfortunately, that's not our final answer because we can combine some like terms. Are there any other cubes to combine this with? So just bring it down. And I like to cross it off so I don't get confused. Negative 2m squared n2 plus 4m2 squared m2 n squared. Negative 1 plus 4 is not negative 3, but positive 3 m squared n squared. Negative 2mn minus 4mn is, and then the negative 8 has nobody to combine with, so he just drops down. Yep. Not real difficult, just kind of lengthy. All right, we have 2 sentences to write, and then we're done for today. The set the set of all polynomials is closed, and I'll explain what that means in a minute, under addition, subtraction, and multiplication. And for you good avid students out there, I'm going to highlight close because that's important. All right, everyone understands what that means perfectly, correct? Like, no. Except for the close part. All right, this is what it means when this is translated. When you add, subtract, or multiply. Can you give me 2 minutes?
Sure.
Thank you.
Want me to wait inside or outside?
Inside's fine. No. 2 polynomials the answer is still multiply. When you add, subtract, or multiply 2 polynomials, the answer is still a polynomial. For example, if I was to divide x squared by x squared, what would my answer be? X squared divided by x squared would be 1. So, I guess that's a polynomial. But we can divide and have it come out so it's not a polynomial. That's all it's saying. All right, let me stop the tape.